So what we have here is a challenging differentiability problem. Usually it's not too difficult, but this one has a piecewise function, and it definitely makes you review what it means to be differentiable. Okay, so there's some good calculus concepts to cover for this problem. All right, so definitely pay attention to those and the calculus ideas. All right, so let's get started. If they say that f of x is differentiable at x equals 1, then you can draw these conclusions. On one side, it means that f prime of 1 must be equal when x is approaching 1 from the left and x is approaching 1 from the right. Okay, so basically it means that the derivatives on both sides, or for the pieces of the function where x is greater than 1 or x is less than 1, the derivatives of those must be equal to each other. So I showed you that in the limit form of what I just explained. You might need to know this for the free response, so I just wrote it out for you guys. Okay, but let's actually go ahead and take those derivatives and make them equal each other. Okay, and maybe we'll get somewhere. So here we go. F of x was 1 over x plus 1. You know what? I'm going to go ahead and rewrite that as x plus 1 to negative first power. Go ahead and take the derivative. And now plug in x equals 1 to find the actual derivative at x equals 1. So that will be negative 1 over plus 1 squared. It's negative 1 over 4. Okay. The other equation was f of x equals ax plus b. We take the derivative though, okay, because b and a's are both constant, or b is a constant, a is a coefficient, derivatives can be a. Okay. So remember, the derivatives, if it's differentiable, then these two are equal to each other at x equals 1. Okay. So basically a equals negative 1/4. And that's a useful piece we'll use later on. Okay. So here's a second conclusion that will help us. If f of x is differentiable at x equals 1, then f of x is also continuous at x equals 1, which means what you'll do is plug in x equals 1 for both pieces and then set them equal to each other. Okay, because that's what it means to be continuous. And the idea is that, obviously you can't differentiate where it's not continuous, where there's a hole or an asymptote. Okay, so this conclusion totally makes sense. Let's do this. F of 1 equals 1 over 1 plus 1. And then for the other one, f of 1 equals, so remember a equals negative 1/4, x is 1 plus b. So we can use this to find b now. Let's go ahead and set these equal to each other. Add 1/4 to both sides. 3/4 over equals b. Yeah, okay. So now we have b. We can find what we're supposed to look for. F of b minus a. Take it all the way now. F of b, b is 3/4 minus a, which is negative 1/4. So that will give you f of 1. Now, the equation you want to plug into is the first one, because that's valid for x when x is equal to 1. Okay. So that's going to be 1 plus 1. That's just 1/2. Okay. So the twist at the end isn't so important as the calculus ideas for differentiability. So hopefully you review that, or at least somewhat familiar. Okay. Thanks for watching.